Cosine similarity is helping us to understand how similar the words are using the inner angle that is there. That is, instead of just considering the distance, we are also considering the angle between the these vectors. So the problem with the Euclidean distance is that it is biased by size difference in representation. Let us see, if I have fewer representation for entertainment and more representation for machine learning, then it will get affected. So rather than that, I would want the angle to be considered, along with the vectors. And this is where the cosine similarity helps me. It is the dot product between the two vectors. So the magnitude of the vectors into the cos theta, which is nothing but the angle between the two vectors. So now we are going to see how do we calculate the cosine similarity. Consider if I have two sentences. AI is a friend and it has been friendly. And the sentence 2 is AI and humans have always been friendly. So in step 1, we will calculate the term frequency. So AI appears once, appears, friend appears twice, human does not appear, always does not appear, and been, are, it, has appears. Similarly, for sentence 2 also, we mark the term frequency. Now, we have to calculate the L2 norm for each of these sentences. What do I mean by L2 norm? L2 norm is nothing but the root of these terms square. So, it will be root of 1 plus 2 square, which will be 4, plus 1 plus 1 plus 1, 1 and a 1. So, it will give me 1, 2, 6, 7, 8, 9, 10, 11, root of 11. And the L2 norm for this particular sentence will be 1 square plus 2 square plus 3 square, 1 square plus another one, 3, 4, 5, 6, 7. So root of 7, that will be the L2 norm. So we calculate the L2 norm so that we normalize the term frequencies. So once we calculate the L2 norm, we divide these words. That is, we calculate 1 by the L2 norm of sentence 1, which is 3.3166. And here for the second one, we divide 1 by 2.6458, which is root 7, which is the L2 norm for the sentence 2. So that now this is done so that we otherwise it will favor the sentences that are longer. So it will favor the sentences, and so to avoid that, we make use of L2 norm here. So once we get L2 norm, we calculate what is the product of these two sentences. So 0.302 into 0.378 plus this becomes 0. 0.603 into 0.378 plus 0 plus 0 plus 0.302 into 0.378 plus 0.302 into 378 plus 0 plus 0 plus 0.302 into 378. So we are getting 1, 2, 3, 4, 5 terms. So 1, 2, 3, 4, 5 terms we are getting, and 0.684, indicating that the similarity between the two sentences is 0.684, which is nearly 0.7 and closer to 1, indicating that the two sentences are similar. So here closer the words, the vectors, the value will be more, and the farther they are, like entertainment and machine learning, it is 0.18, indicating that these two are totally different topics. So when the cosine value is 0, that means the vectors are not matching, but then the cosine value is closer to 1, indicating that there is a match between the two values. Now let us see with Jaccard coefficient. So now consider if we want to know the relationship between two similar words such as king and the man. For that, we have to check the vector representation between the two. And then we can add the vector representation between king and the man so that we understand what is the word that it is applying. Consider if I want to check the vector representation of the word queen. Now king minus man plus woman will give me queen. So here I have the vector representation for all. So king minus the man plus the woman will give me the vector representation for queen. So like this, when I have the vector representation, I can check on the words also. Now let us check what is Jaccard similarity. Now Jaccard similarity is intersection over union. It's also called as intersection over union, and it is nothing but the size of intersection divided by the size of the union. So taking on the same sentences, we will first of all check the perform lemmatization, and then see, these are the common words. These are the words which appear additionally in one sentence. These are the words which appear additionally in another sentence. So the total number of words that we have here is 10, and the common words is 5. So 5 by 10 is 0.5. 0.5 is the value that I get for Jaccard coefficient. But 0.684 is the value that we got for coefficient similarity. So there are certain differences between Jaccard similarity and cosine similarity. Jaccard similarity will take only unique set of words, whereas cosine similarity will take the total length of the vectors. If there is anything that's repeated, cosine similarity will get affected, but Jaccard similarity will only check for the presence of it. Even if it is appearing 50 times, it does not matter. So cosine similarity is basically checking how many times does it appear also, but Jaccard similarity is not affected by the number of times that it appears. So Jaccard similarity, for the same reason, it makes sense where duplication is not important, but where duplication becomes important, cosine similarity is all the more better.